I'm going to take you through a zero-touch demo, and with that in mind, I'm obviously not going to do too much as far as this is concerned. So our scenario is that we have a new VM with a pre-installed robot. It's just started. It registers with a hub and then gets discovered. And once discovered, it then gets added to various groups that are already defined with monitoring, and then MCS will start to push out that monitoring. So let's go to the inventory, and the device that I have just started is called OANOSS1. We can see it was started or discovered a minute ago. So what I'm going to do on the right hand side here is I'm going to find this device, and then we can see that only the robot is installed. No probes are installed on there whatsoever. So I'm going to leave that to the right hand side. I'm going to talk to you about MCS, and then as I'm talking, that will get updated, probes will be pushed out, monitoring applied, and so on. Okay, so there's four main parts to MCS: groups, templates, profiles, and policies. And within the MCS UI, there's no concept of hub, robots, or probes, just devices and monitoring functionality. So the idea behind MCS was that you could offer this as a service to your own end users, so that they could, using the multi-tenancy, you can create accounts. They can only see their own devices. They can group those devices as they see fit, and then they can start applying monitoring to those groups or the devices. So let's have a look at the groups. So most of you will be familiar with the groups, but just in case you're not, we'll go through a little bit. So as far as MCS is concerned, if we think of a group as a super package, because with the configuration and the profiles that you can define, it's basically a set of configuration all coming from different probes and all in one place. And then if the probe is not present at the robot, the probe will be deployed by MCS. So if a device, as in what's going to happen in this case, is added to a group or groups, that monitoring will automatically be deployed. And similarly, if a device is removed from a group, all of that monitoring that was part of that group will then be undeployed. So it tightens up after itself as well. So in our scenario that we're using here, we're actually just using dynamic groups. But of course, you can use static groups. There's no difference between the two other than the way that the devices are added to the groups. But using the static group, of which some customers are happy to use the static groups, they can have all their monitoring set up on a static group. And when a new device comes along, they can either manually add it, or they can use an API call to add a device to a group. And once they do that, the monitoring can be applied. But for our case, it's just we're using dynamic groups as automatically. And I can see already that on the right-hand side that CDM, NetConnect, and processes probes have been installed already. So MCS is busy working while I'm talking. Okay, so grouping, as you know, is done using attributes of devices. There's a lot of attributes to create or to select, and you can also create your own attributes. And we'll talk about that with application discovery as well. Okay, so templates now. So let's have a look at some of the templates. So just in case you're not sure what a template is, you know, all of the probes are controlled by configuration files. Well, a template is a section of a configuration file, but it's never the entire file. It's generally broken down into what makes more sense. So if we take the example of CDM, we've got CPU, disk, and memory, and we can break those templates down into those three different sections. As well as that, we also have every probe has a setup section where you can set the log level, the log size, credentials, and so on. And you wouldn't necessarily want to offer this out to an end user because they don't know what a probe is. So why would they want to set the log level? So with that in mind, you can actually associate an ACL with a template. So if the user doesn't have that ACL, they cannot use that template. So things that administrators would do, you can associate ACLs and hide those templates, or at least that functionality from them. So when you have, so basically there's one template, and you know, thousands of profiles can be created from that one template. So, you know, a template is basically a set of a section of a configuration file with the key value pairs. The keys are then displayed, and then you can set the value, either on or off in most cases, so it could be a threshold or alarm and so on. So that's basically what a template is, and some of the templates are restricted to the number of profiles that you can create per probe per device. So the setup section is a good example. There's only ever one setup section, but it belongs to every single probe, or there's one for every single probe. So you wouldn't want to create multiple setup sections for the same probe on the same device. And again, the same applies with CDM, whereby those sections are predefined within the CDM configuration file. So you don't want to be overwriting them with multiple copies of it. You just have one. If you need to update it, you only update the one that exists. So you can have local templates or remote templates. So a local template basically requires a robot, and the robot should be, the robot is installed, the probe is required, and so on. And that's 99% of all of the templates are local templates. But you can do remote templates for agentless monitoring, so NetConnect and RSP. So you can select a device that doesn't have a robot on it. You can still go to MCS. It will give you a subset of templates, and those templates will just be for NetConnect and RSP. You obviously have to select a device where NetConnect is running or RSP is running, but once you've done that, all of the metrics, alarms, and everything are associated with that remote device, not with where they're being monitored. So users can still go and monitor their remote or agentless devices. So templates, let's just go to the template list we have here. So in case that wasn't clear, actually what I did, in the gear icon here is MCS. That then gives you a list of your profiles that are available, and then to go into the plus then gives you a list of the templates. And the list of templates will differ from site to site because you have to install the templates that you're interested in using. They come as a package in the archive, so when you download a new probe, you can also download the templates and just load them to wherever monconfig service probe is running, and then you'll get the templates here. So I'm going to just filter on CDM. I know I said there's no concept of probes, but if you happen to know it, it's kind of hidden, but it will filter on those. So you can see here that there's a doubling up of every single probe, every single template that we have here. So we've got an enhanced one, so we've got a legacy template and an enhanced template. So a legacy template gives the whole of the control to the probe. So you have the metrics, thresholds, alarms, all done in a legacy template, and that gets written to the probe, and the probe just does everything. But an enhanced template works in a very different way, and it's important that you understand the difference between the two. So now if we go to an enhanced template that we have here, now firstly, an enhanced template can do everything as well. It can do the alarming, the thresholds, and the metrics, but the moment that you turn on the alarm policies, you can only do metrics on an enhanced template. So that they exist, but it's hidden from you. So if you're using the alarm policies, you'll only see metrics in these templates. And the way that all probes work is that when they have a metric or an alarm to publish on the message bus, they don't do that. They pass that to the spooler, and it's the spooler that has a connection to the hub, and it will publish the messages on the message bus. So that's the way it works today. So what we've done with the enhanced templates is we've added a bit of intelligence into the spooler so that it will look up configuration before it publishes things onto the message bus. So you can see that in this template we have approximately 20 different metrics that are available, but only 7 of them are turned on. So this definition here goes directly to the spooler, not to the probe. So the probe has, or should I say the spooler has a configuration file called plugin_metric.cfg. And this definition goes directly to the plugin metric file, not to the probe. The probe currently is told to just turn on all metrics. So if you were to do this tomorrow just as a test to see how it works, and you then use an infrastructure manager or admin console, go to that probe, you're going to think, well, hang on, all 20 metrics are turned on, I only turned on 7. And that's because the control is now with the spooler. So the probe will locally pass them all to the spooler, and then the spooler will determine on this definition here in this enhanced template, which it has in the plugin metric file, what gets published and what doesn't. Now, we are aware that that's not the best way to do it, to send all metrics. So that is being undone, and it will be reflected. This configuration will be reflected both in the probe and in the plugin metric.cfg file. So be aware that that's changing. But if you were to try this out tomorrow, you'll see everything turned on. But that will change, and it will change soon. So once you create an enhanced template, a default alarm policy also gets created, and this alarm policy is given directly to the spooler. So again, in the plugin metric file. So no alarming is coming from the probe. It's all coming from the spooler. The spooler receives the metrics. It knows the values. It can then look up what the thresholds are and determine whether it needs to create an alarm or not. And it will do that for all probes. So the control is taken away from the probes. Alarming control is taken away and then given to the spooler. So it's important you understand when you're using enhanced templates, the spooler plays a big part, and the configuration isn't just at the probe. It's also in that plugin_metric.cfg file. Okay, so profiles. So profiles are obviously where you define your monitoring. This is a profile that I have in front of me. I already mentioned that basically it's an instance of a template. Template defines all the key value pairs, of which they're represented here with worded strings, and you can turn them on or off. And so the profile that's what gets written out to the probes. So just remember, there's only one template. Of course, there might be updates from time to time, but there's one template, hundreds or even thousands of profiles that get created off of that template. And profiles can be created on a device or a group level. Obviously, at the group level, you can create one profile. I'm in this group open access infrastructure, has 28 devices in there. If I create a group profile there, it gets pushed out to all 28 devices in this group. So, or you can go directly to the device itself. And within group profiles, we have a priority. And now this priority denotes which profile will actually be deployed. So let's say you have a device that belongs to multiple groups, and some of them have the same profile defined in them. Whichever one has the highest priority, that's the one will be deployed, regardless of which group it's in. The highest priority wins, basically. So, and if you don't change the priority, so the default is 100, and you create a new profile, but there's one already exists from another group, that will actually, the one that's currently there will stay there because this one doesn't have the priority to overwrite it. So that's the way that works. And just, lastly, as we've mentioned, that if the probe's not installed, MCS will deploy the probe for you. As we can see on the right-hand side, we have several probes installed, and I've done nothing but talk about it. So now let's have a little look at the alarm policies. There's various ways to get to the alarm policies, but if we go to settings and then alarm policies, we're then presented with a list of all of the alarm policies. And you can see that the ones with the creator of CA default policy, these are the ones that are created by MCS as you create the enhanced templates. These get created for you, but if you don't want those, you want to use your own, you can disable them. As you can see, some of them are disabled, or you can delete them. It's entirely up to you. And you can even tell MCS not to create them in the first place. That's a configuration option as well. So if we have a look at, so I've set up, I've called it basic alarm policy. There's nothing basic about it other than it's, the first or the last resort, really. So so you can see here, so I've given a very low priority, lower than the default one. So if no one else creates an alarm policy for these particular metrics, these will still alarm. But if so, this basically covers you that yes, we're covered, that we've got all of our alarm policies pushed out there. And if users then want to come along and create their own with you know, you can specify. So we just look at the alarm text, for instance. You can change the language. You can use different variables. They can do that however they like. And if they supersede, just give it higher priority, it's going to supersede your default one that's been pushed out. Now, notice that in this particular alarm policy, I'm using 3 different groups. So I've got the open access infrastructure group looking at NT services state. I've got the MCS devices with the database status, and then also in the zero touch group response time. So I can have one policy that can span multiple probes, multiple groups, and you can have, you know, if we were to create a new condition, we can do a device or even a monitoring technology. We can do it at that level as well. But for the sake of this, it's just set up for groups. And you can have, obviously, when you set up your thresholds, you can have multiple thresholds. You can change the actual threshold and change the severity. You can have a static or dynamic, so long as you have the baseline enabled. You can work off the dynamic, and then you can have them so they alarm immediately, or you can say, okay, I'm not interested if I get 2 errors, but if I get 3 in 15 minutes, then I want to see an alarm. So, you know, all of this is done in the alarm policy, and this is then pushed out, and it gets pushed out to the plugin metric file. Okay, so this is how you do your alarm policies. Okay, so let's have a little look at our device to see how it's got on. It hasn't been a great deal of time, obviously, so let's just see if we've let's get to the inventory, see whether we've got any metrics. And so we have here, we have got some metrics. So I've done nothing. That was a brand new device, as you saw, and we've got metrics already. And I believe also we have, oh, we got no alarms. We did have some alarms. They come and go, the alarms, so it's a timing thing. Perhaps I'll check back in a little while. But basically, we've got metrics. Once we've got metrics, we've got any alarm policies pushed out, which we have. It'll alarm as well. So now let's have a look at what was done to this device. Remember, it's a brand new device. So if we look in within MCS, we can see the profiles that have been created, and we can see where they have come from. So you can see there's 3 different groups. We've got a MySQL group, open access infrastructure, which is the one we were looking at, and also we've got the Unix group. Now the Unix group is part of application discovery, which is what I want to talk about now. So, and also so is the MySQL. So if we go back to groups and we'll look up application discovery, and in the setup application discovery, we basically set them up as 2 different types, if they're Unix devices or if they're Windows devices, which is pretty straightforward. So now if I go to this group, so obviously every device is going to hit this, either regardless of Unix or a Windows, and these profiles would be deployed to those devices. Now, behind every template is something called a deployer, and the deployer tells MCS what to do with the data that's been saved in this profile. Now, normally that is just, or should I say 99% of the time, that is just get this data and create this section, this configuration file, and that's it. But occasionally there are deployers that do other things. So this deployer for the application discovery, yes, it sets up a configuration section, but it also deploys a little probe over to the device. Now, these probes that get deployed are very lightweight, very simple, and they can be run at, you know, whatever interval you wish, once a day, you know, every 15 minutes or however long you want to run them, just to see if an application gets installed. Now we can see over here that MySQL probe was actually installed. So this AppDisco MySQL script obviously ran. It's discovered that MySQL was running. So this thing does no more than what's running, and is one of the processes called MySQL-D. If it is, we know that MySQL is running on this device, and that's exactly what's happened. So what these application discovery scripts then do is they create a new attribute for that device, which is written to the nizcas on that device and then picked up by Discovery Server and makes its way back to the database. So this then means that this new attribute is basically a role. So we say, okay, this device has a role of MySQL, and it can have multiple roles. Obviously, if it found some of the other applications on there, it would have multiple roles. So now we are able to group devices on their roles. So, and this is exactly what application discovery does. And just before I forget, I've written a blog about application discovery and how you can write your own scripts, and that's available on the UIM Academy, just while I remember. Okay, so now we can see, okay, so now in the discovered applications, we can see there's a MySQL. So a MySQL, of which our device will be part of, it's AONOSS1. We can still see it up here, and we see MySQL's installed. So let's just have a quick look at the profile here. So one thing I wanted to talk about was, so within this profile, you can see that the MySQL server actually uses an attribute, and the attribute is called device.ip. Obviously, the IP address is going to be different for all of these devices, and we need that to be able to connect up to that MySQL instance. So attributes are not just used for grouping; they can also be used in the profiles themselves. So we can see that's device.ip. If we go to our new device that's just been created, and we're going to just look for the MySQL, discovered MySQL, and then we can see that the value of that field will be the IP address. So we can see that the IP address has been substituted there with the value from the attribute, and that's obviously going to differ from device to device. And just to show you another thing we can do with attributes, and you may have come across this, I don't know if you've used MCS already, you may have seen this. So attributes can have multiple values, and you can use this within MCS as well. So now what I've done is, so we're looking at SQL Server instances now. So I have a device, so there's a different device now, not the one we just created, that's called OAIMDB. And I've basically, using the UIM API, just got some information about it, and I can see that these are the attributes that are available on this device. And I've got an attribute called MySQL Server Instances. I have 3 values: MS SQL Server, MS SQL or SQL Demo, and SQL UAT. So there's 3 values that are available on this in this attribute. So now we can use those 3 values. So what I've done is there's something called for each. It's at the top of all group profiles, or most group profiles, and we've enabled that. We've given it a name. That's just the name of the group profile. And then here we have a list of all of the attributes that are available to us to use for this for each. So I'm using my SQL Server instances. Now, SQL Server instances, we know have 3 values. So if you want to, you reference it as a profile name, we need each profile name to be different. So we're going to use the for each instance, which will be one of those 3 values. And then within the profile itself, again, we can use the device.ip. Then we can use the profile name, which is the same as the for each instance, because if that's what is populating that field. But you can only use for each instance once. So use that in the profile name and then reference the value as profile name. So now we've done that. So we've created one profile at the group level. But now if I go to the device level, so I'm going to select this device. I'm going to just order by group once it comes up. So these are all of the profiles. So now we can see the for each. So for the for each group, I've got one MS SQL Server, SQL Demo, and SQL UAT. So all 3 of those have got created just from the one profile. And you can see now that I've got the IP address done, I've got the SQL UAT and the port number. And if a device doesn't have, so if a device in this group doesn't have that attribute, it won't create any profiles. If it's got one value, it will create one, seven, it creates seven, and so on. So that for each will just loop through every value it finds. If it doesn't find it, it won't create one. And even if you update that variable and add in or attribute and add in a new value, it will then create add a new profile for you. And that's pretty much what I was going to show you today.